Hello students, today we are going to learn about the alkali metals present in the periodic table. Are you ready to explore this interesting group of elements? Let's begin. The alkali metals are lithium, sodium, potassium, cesium, francium. Some important points about alkali metals. First, we will state where the alkali metals are located in the periodic table. Second, we will describe some of the physical and chemical properties of the alkali metals. And finally, we will write word equations to outline the reactants and products of their chemical reactions. So, students, let's start learning about these interesting elements step by step. Location of the alkali metals. Now, let us talk about the location of the alkali metals. The alkali metals are located in Group 1 of the periodic table. This is the very first column on the left side of the periodic table. All the elements present in this column are known as alkali metals. Physical properties of alkali metals. First, let us talk about softness. Alkali metals are unusually soft for metals. In fact, they are so soft that they can be easily cut with a knife. Next, we discuss density. Alkali metals have very low densities. Because of this, lithium, sodium and potassium can even float on water. Finally, let us talk about melting points. Alkali metals have relatively low melting points compared to most other metals, which usually have very high melting points. Also, the melting point decreases as we move down the group. This means lithium has the highest melting point among the alkali metals. Reaction of alkali metals with water. Now, let us look at the reaction of alkali metals with water. Reaction of lithium with water. When lithium is placed in water, it fizzes slowly and gradually, moving gently on the surface until it eventually disappears. Reaction of sodium with water. When sodium is placed in water, it fizzes much more rapidly, moving quickly on the surface and soon disappears. Reaction of potassium with water. When potassium is placed in water, the reaction becomes even more exciting. It sparks, releases a beautiful lilac flame, and then rapidly disappears. As we move down the group, the reactivity with water increases. In fact, the last three alkali metals react very violently and can even become explosive. Reaction with water equation. Now, let us understand the reaction of alkali metals with water and the equations involved. Positive ions, Group 1 elements all have one electron in their outer shell. Because of this, they show similar chemical properties. When Group 1 elements react, they lose this one electron and become a positively charged ion. These ions now have a full outer shell of electrons, which makes them more stable, producing hydroxides. When alkali metals react with water, they produce hydroxides. Hydroxides are known as bases. They dissolve in water, have a pH above 7, and they turn universal indicator blue or purple. Word equation for the reaction of sodium with water. Sodium plus water, sodium hydroxide plus hydrogen. Reaction with oxygen. Now, let us understand the reaction of alkali metals with oxygen. Oxygen in the air reacts slowly with the surface of alkali metals, giving them a slightly white appearance. When alkali metals react with oxygen, they form metal oxides. If these metals are heated with oxygen in a closed or contained space, the reaction can become quite vigorous. Word equation for lithium reacting with oxygen. Lithium plus oxygen turn lithium oxide. And remember, reactivity with oxygen increases as we go down the group. Reaction with chlorine. Now let us understand the reaction of alkali metals with chlorine. Alkali metals react vigorously with chlorine to form metal chlorides. At room temperature, these metal chlorides are white solids. They dissolve in water to produce colorless solutions. Word equation for the reaction of sodium with chlorine. Sodium plus chlorine to sodium chloride. And remember, the reactivity of alkali metals with chlorine increases as we go down the group. Trends in reactivity. Now let us understand the trend in reactivity of alkali metals. When group 1 elements react, they form positive ions 1 plus by losing one electron. The easier it is to lose this electron, the more reactive the alkali metal becomes. As we go down group 1, the size of the atoms increases. The outer electron moves farther away from the nucleus. Because of this, the force of attraction between the nucleus and the outer electron becomes weaker. As a result, the outer electron is lost more easily, and therefore reactivity increases down the group. Well done, students! This is all about the alkali metals in the periodic table. I hope you enjoyed learning about their properties, reactions, and reactivity trends. Thank you for connecting with me. See you again in the next chemistry lesson.